So the topic that I chose is the components of chemistry that go into cooking and baking. So people oftentimes do not realize the overlap between making food and chemistry, which isn't unfair of them to think because people don't really see chemistry as much more than pouring liquids into beakers and seeing if they blow up. But there are a lot of different types of chemistry that we can see in our day-to-day life. And one of the most prominent is the way that chemistry is within all of our cooking and baking. And some prime examples that we can see of this is what happens when you chop an onion, or when a cake rises or leavens, or when it browns, and the same thing can be seen in bread. And we can just see chemistry in many different ways when we're in the kitchen. So it's not just pouring chemicals into beakers, we just don't realize that's what it is because we're not thinking about it.
Onions are an excellent example of the chemistry that goes into cooking. Often, when chopping onions, people will complain about their eyes watering, which is due to the natural components and chemicals of onions. Onions have a component called the lacrimatory factor, which reacts with the eyes, causing them to water as your eye tries to clear itself. The component is an enzyme called the lacrimatory factor synthase.
So as already mentioned in my presentation, one easily visible chemical reaction we can see in the kitchen is the way that cutting onions reacts with our eyes. So the reaction of your eyes watering up is actually caused when you cut into an onion. And this is because this releases the moisture inside of the onion, which contains an enzyme called the lacrimatory factor synthase. And what this enzyme does is it reacts with our eyes in a similar manner to tear gas. So after you've been cutting at an onion for a while, it causes your eyes to water up due to the reaction. However, another thing that we can see in the kitchen is the way that eye protection keeps bad reactions from happening between what you're working with and your eyes, because I wear contacts, so the way that an onion reacts with my eyes is very different from the way an onion reacts with my parents' eyes. So that's just two really cool things that you can see when you're cooking in the kitchen and you're thinking about chemistry. So, yep.
Bread rising is another example of the chemistry involved in baking. Bread rises due to a reaction between gluten, salt, yeast, starch, and water, among other smaller components. When the starch is found in flour turned to glucose, it reacts with the enzymes in the yeast, and when combined with the other ingredients, these things cause bread to rise. Another version of this reaction uses baking soda. Baking soda reacts with acids in the dough to make carbon dioxide, which helps the dough to rise.
Another example of chemistry in the kitchen would be cakes when they brown. So if you've ever baked a cake, you'll oftentimes notice that the outside of the cake is more stiff and less airy compared to the inside of the cake. This is because of a reaction called the Maillard reaction, which is a chemical reaction between amino acids, proteins, and reducing sugars. This reaction, also known as browning, is what causes the crust-like outside of cakes, and this reaction occurs when the sugar in a cake is around 300 degrees Fahrenheit. Baking bread also includes a reaction called leavening, which causes the empty space in bread as well as its light, airy texture. This reaction uses leavening agents such as baking powder and yeast. Baking powder, which is baking soda plus an additional acidic salt, releases carbon dioxide twice during the baking process, one time when it touches water and then another time when it reaches a certain temperature in the oven. Heat helps baking powder produce tiny bubbles of carbon dioxide, which make bread light and fluffy. When yeast, which is a single-celled fungus that feeds on starch and sugars, is added to the dough, it also releases carbon dioxide bubbles. This is what gives dough a light, delicate texture. Arguably, the most important part of learning is knowing how what you've learned applies to the real world, especially in your day-to-day life. So cooking and baking are constantly happening around the world. If it's not happening where you are, it's happening where someone else is. So there is always a chemical reaction taking place purely because of that. And so knowing that chemistry can be seen in your day-to-day life and being able to recognize it is what makes learning it all the more fun, because no one wants to learn something they're never going to use. But in chemistry, we can see the way that it applies, because we can see a cake rise and go, oh my gosh, I know what causes that. It's chemistry. Or when you cut an onion and your eyes are watering, you're like, wow, this chemistry is incredible. So it's really cool to be able to take your learning into your own hands and see the way that it applies to the world around you.
This topic relates to the chemistry standard of reactions. Standard CHM.2.2 says students should be able to analyze the evidence of chemical change. We can see this demonstrated in the chemical changes that take place in baking specifically, when bread rises, leavens, and browns, as well as the reaction that causes our eyes to water. We've done a lot of work with really interesting reactions this year, which was what inspired my topic.
So that concludes my presentation. Once again, I'm Elise Edmondson, and this has been the components of chemistry that go into cooking and baking. Thank you.